Hello, my name is Joe Green, and today we will be going over polynomial functions and models. So to start, we have perpendicular slopes. If you have a slope of -2, that means the perpendicular slope will be 1/2, and that is because the perpendicular slope is the negative reciprocal of the original slope. So say we have a slope of 3. That means our perpendicular slope will be -1/3 because that is a negative reciprocal. Say we have -4, perpendicular slope will be 1/4. Moving on, we have to construct a polynomial function with the zeros 1, -1, and 2 with the degree of 3. So we see the zeros 1, -1, and 2. We'll list them out here. 0 of 1 equals x minus 1. 0 of -1 equals x plus 2, or x plus 1 rather. And 0 of 2 equals x minus 2. So we have the zeros listed. Now with the degree of 3. See, degree is the highest exponent in the function, right? So say you have this function right here, x4th power plus x to the 3rd power. X to the 4th power is your largest exponent, so that means your degree is 4. So for this one, once you multiply all of these numbers together, your highest exponent will come out to be x cubed, so the degree of this function is already 3. Now multiplicity is basically how many times this 0 will show up. So I'll rewrite our old function that we just did, x minus 1, x plus 1, and x minus 2. So we know all of these zeros only show up once, right? So this has a multiplicity of 1, since it only shows up once. This has a multiplicity of 1, since it only shows up once. And this has a multiplicity of 1, since it only shows up once. Now, say we took our original function. I'm going to rewrite it real quick. Say we took our original function and decided to do this. Now, x minus 1, now the 1, which is the 1, that's the 0 of this, has a multiplicity of 2. And these still have a multiplicity of 1. And that would also make the degree of this function 4. Because when you multiply all these out, the highest exponent you'll get will be x to the 4th. Now for turning points, it's pretty easy. It is the change from decreasing to increasing, or more easier, n minus 1, which is the degree minus 1. So again, say we rewrite our original function one more time, one final time. Here's our original function, and it has, we'll go back over here, the degree of 3. So since the turning point is n, or degrees minus 1, that means this function has 2 turning points. It might actually look something like this graph right here. This is just a sample graph, just to show that the one turning point is here and the other turning point is here. So that means this function has the degree of 3 and 2 turning points.